Assalamu alaikum students. This is the physics lecture for class 8 of chapter 2. This is the outline of today's lecture. In this lecture we will do topic 2.7 from page number 49, example 2.14 from page number 49, example 2.15 from page number 50, numerical 2.4 and 2.8 from page number 54, and the exercise question 2.1 page number 52 and 53. This is the book we will use from Karwan Book House, Physics Class 9th. The topic of today's lecture is motion of freely falling bodies. Before moving towards the topic, first we have to clear the concept about the title, the words used in the title of the topic. The first word is motion. As we all know, motion means movement. When something is changing its position with respect to its surrounding, then that body is called in motion. The next term in the topic is freely falling bodies. Falling bodies mean when something is moving from some height. It is falling from some height towards the earth. Obviously, whenever a body moves, a force is responsible for its motion. Here no force is applied, but the force responsible for freely falling bodies is the gravitational force. The force of gravity is responsible for the movement of the body because, as you know, gravity is the force which is pulling everything towards earth. So the gravity is attracting this ball and the ball is moving under the influence of gravity. As you can see, the ball is falling towards the earth. In motion of freely falling body, as we know that the gravity is responsible, so the acceleration happens, the movement happens because of gravity. So gravitational acceleration is involved. The acceleration due to gravity produced in a body is called gravitational acceleration, and it is denoted by small g. On the surface of earth, its value is 10 meter per second square. Whenever the body is freely falling or moving under the gravity, then the acceleration involved in that case is gravitational acceleration. And equation of motion for those bodies are Vf is equal to Vi plus Gt. Here we have replaced normal acceleration A with G, which is the gravitational acceleration. Second equation of motion is H is equal to Vit plus half Gt square. Now in freely falling body cases, the distance body covers is the height. So we have replaced distance with height and acceleration with gravitational acceleration. The third equation of motion is 2gh is equal to Vf square minus Vi square. Here we have replaced normal acceleration with gravitational acceleration, and the distance which the body is covering is height. In case of motion of freely falling bodies, we have some sign conventions that gravitational acceleration is positive for the bodies moving downward and negative for the bodies moving upward. So if the body moves upward, please observe the motion of ball very carefully, that it will reach the highest point, stop there, and then came back. Now at initial level, the initial velocity has some value Vi, but at the highest point, final velocity of the ball was 0. That's why it came back towards the earth rather going upward. So by putting the values in acceleration formula, final velocity 0 and initial velocity Vi generally, so we will get acceleration negative. But in the case of body moving downward, we had some value at highest point, initial value, and the final value at the ground level. So by putting the values in case of bodies moving downward, G is positive. Now this is example 2.14. A stone is dropped from the top of water. The stone hits the ground after 5 seconds. Find the height of the tower, the velocity with which stone hits the ground. So when the body is moving in vertical motion, obviously the acceleration is gravitational acceleration, and when we are dropping the body from the height, its initial velocity is 0 and had some final velocity. So the time taken by the ball is 5 seconds, and we have to find out some height it has covered and the final velocity. Here is the formula list. From the given data, we have to observe that which formula is suitable for the things we have to find. So in first part we will use second equation of motion, because we have to find out the final velocity and we have the value of initial velocity and the time. So by putting the values in this equation, we will get height is equal to 125 meters. Now we have to find out the final velocity. So by using the equation third, which is 2gh vf square minus vi, we will put the values in it and we will find out the value vf is equal to 50 meter per second. In example 2.15, a boy throws a ball vertically upward and it returns to the ground after 5 seconds. We have to find out the maximum height reached by the ball and the velocity with which the ball is thrown up. So in this case, the gravitational acceleration has negative sign and the time is 5 seconds. Now we have to find out the height and the initial velocity. If you look at this formula list, to find out the height, we need initial velocity and time. From the given data, initial velocity is unknown. So we will move towards third formula. Once again, in this formula, we have final velocity and initial velocity. The initial velocity is missing. So first we have to find out initial velocity to find out the height. So to find out initial velocity, look at this formula list. The formula 1, Vf is given, G is given, T is given. So by using this formula and putting the values in it, we will get initial velocity 25 meter per second. And to find out the height, now we will use second equation of motion, and by putting the values in it and solving it, the height will be 31.25 meters. Here is a very tricky point, that in every solution we have used the time period 2.5 second. The reason is this, that the ball has taken time 5 seconds to return to the ground. It means it has reached upward point and then came back to the earth. So in this whole trip it has taken 5 seconds. So when the ball has moved upward, the time taken by the ball is half of 5 seconds, which is 2.5 seconds. That is why we have used 2.5 seconds in both solutions. In problem 2.4, a tennis ball is hit vertically upward with a velocity of 30 meters per second. It takes 3 seconds to reach the highest point. We have to calculate maximum height reached by the ball and how long it will take to return to the ground, the time taken by the ball to return to the ground. So the given data is acceleration is minus 10 meter per second, because the ball is moving upward. Initial velocity is 30 meter per second. The final velocity is 0 because at highest point the body stops, so its velocity became 0. And the time taken by the ball in half rev just in reaching highest point is 3 seconds. In problem 2.8, a cricket ball is hit vertically upward and returns to the ground 6 seconds later. Calculate maximum height reached by the ball and initial velocity of the ball. According to the given statement, obviously the body is moving vertically, so the acceleration is gravitational acceleration with negative sign, and the final velocity of the ball is 0. The total time taken by the ball is 6 seconds. It means it has covered 3 seconds in moving upward and 3 seconds in moving downward. The height is unknown and we have to find out the initial velocity as well. According to the formula list, now we have to see the given data and the formulas, that which formula is suitable. First thing we have to find out is height. But here in the formula of height, equation 2 and equation 3, initial velocity is involved and initial velocity is unknown. So first we have to find out the initial velocity, then we will find out height. So by using the formula 1, we can easily find out initial velocity because final velocity, gravitational acceleration and time is given. So by putting the values in this equation, we have found initial velocity is equal to 30 meter per second. But there is a one point that we have to put the value of time 3 seconds, because in 3 seconds the ball has reached highest point and then in next 3 seconds it has reached the ground again. So the time is 3 seconds. Now by using the second formula and putting the values in it, we can easily find out the height, which is h is equal to 45 meters. Now we have the exercise 2.1 in which we will do MCQs on page number 52 and 53. 2.1, here we have to encircle the correct answer. Number 1, a body has translatory motion if it moves along A straight line, B circle, C line without rotation, D curved path. According to the definition, C is the correct option, line without rotation, because the path could be a straight or curved one. The motion of a body about an axis is called A. Circular motion, B. Rotatory motion, C. Vibratory motion, D. Random motion. B is the correct answer. Number 3. Which of the following is a vector quantity? A. Speed, B. Distance, C. Displacement, D. Power. Speed, distance and power are scalar quantities. So C. Displacement is the correct answer. If an object is moving with constant speed, then distance time graph will be a straight line. A along time axis, B along distance axis, C parallel to time axis, D inclined to time axis. D is the correct answer because in constant speed the body is covering equal distance in equal interval of time, so the line will be inclined to time axis. Number 5, a straight line parallel to time axis on a distance time graph tells that object is A. moving with constant speed, B. at rest, C. moving with variable speed, D. in motion. B is the correct answer because in the graph when the body is at rest it is not changing its position, so the distance has a straight line. The speed time graph of a car is shown in the figure. Which of the following statement is true? A. A car has an acceleration of 1.5 meter per meter square. The unit is not correct. A car has constant speed of 7.5 meter per second. The speed is not constant, it is changing continuously, so this is also wrong. C, distance traveled by the car is 75 meter. This is the correct answer. Average speed of the car is 15 meter per second. This is also wrong. Question number 7. Which one of the following graph representing uniform acceleration? Option A and option B are not correct because they are distance time graph. Now look at option C and D. In option C, the velocity is changing uniformly with respect to time, but in option D, the change in velocity is not uniform. So when the change in velocity is not uniform, the acceleration is not uniform. So C is the correct answer. Question number 8. By dividing displacement of a moving body with time, we obtain A speed, B acceleration, C velocity, D deceleration. Option C is the correct answer. Number 9. A ball is thrown vertically upward. Its velocity at highest point is A minus 10 meter per second, B 0, C 10 meter per second square, D none of these. As we know, when a body is thrown vertically upward at highest point, it stops. So when the body stops, its final velocity is 0. Option B is the correct answer. A change in position is called A speed, B velocity, C displacement, D distance. C is the correct answer. Number 11. A train is moving at a speed of 36 km per hour. Its speed expressed in meter per second is A 10 meter per second, B 20 meter per second, C 25 meter per second, D 30 meter per second. From this solution we can see 10 meter per second is the correct answer. Option A is the correct answer. A car starts from rest. It acquires a speed of 20 meter per second after 20 seconds. The distance moved by the car during this time is 31.5 meter, 250 meter, 500 meter or 5000 meter. So from the solution we can see 250 meter is the correct answer.